Hello and welcome, my name is Rob Kerwin and in today's video will be an introduction to bearings. We're going to look at the purpose of bearings, identifying the common parts, understanding loading, types of bearing, and we have some examples. Purpose of the bearing. A bearing is a mechanical component whose function is to guide a rotating assembly. They allow equipment to move at different speeds and efficiently transport notable loads while operating with minimum noise and vibration. They do this by reducing friction between moving parts. Lubrication, grease or oil, is used to further reduce friction and prevent overheating and premature wear. Here we have some of the component parts. We have the outer race here, the inner race which goes on your shaft. This is a ball bearing, so this is shown with balls and a cage. You can have this with the rollers. Example of that bearing there. This is unshielded, so it will be greased manually. A sealed bearing on the right hand side, shown with plastic dust shield, but you can get those with metal as well. Those are sealed for life, greased at the factory. Here we can see the types of loading on the bearing. You have single point loading on the left, either radial or axial, or you can have them combined on the right hand side. Different bearings are designed to cope with different types of loadings, which we'll discuss further. Taper roller bearings are a common engineering selection because they're the only bearing to satisfactorily deal with both high radial and high axial loads. The bearing surface area is larger than ball bearings and so can take higher loads. The bearing splits into two parts and must be carefully installed and adjusted to maintain the correct internal clearances. This example here, if you listen, has failed due to bad lubrication. You can see wear on the rollers and pitting. Here we have an example of a double taper roller bearing. This is on a trailer wheel hub assembly. Just going to remove the wheel. Here we have our hub, grease knuckle there, lubrication point for the bearings, move the end cap. Grease inside there. Remove the split pin from the castle nut. Remove the castle nut. Hub now slides away. One taper bearing in the rear. Slides over the shaft. See the rollers. The second in the front. Notice the direction they're opposing each other. Here we have another example of a taper roller bearing. Again, two bearings opposing each other, this time supporting a cutting drum on a planer. Ball bearings can accommodate fairly high radial loads and moderate axial load, commonly selected for use in automotive design of engines and gearboxes, used for machine tools, large electrical motors. An example here.
Here we have a motor. Going to have a look at the bearing inside of here. Remove the covers. Let's take off the bearing cap and have a look at that. There we have the ball bearing, sealed for life, plastic shielded. See it working there. Here's an unshielded, same design.
Needle roller bearings are very compact bearings capable of handling high radial loads, high speeds, not good for axial loads, very useful where a small space envelope is available, for example a universal joint, widely used in gearboxes, drive shafts. See one now. Here we have an example of a needle roller bearing. This is a universal joint with 4 needle roller bearings around the outside. See the needles inside. Sits on the trunnion. Grease nipple. Greases inside. So this is a universal joint from a power takeoff arm on tractor. So this works by using 2 yokes opposing each other. One will be in this orientation, one like that. So this one would sit there. Universal joint would sit inside, allowing the yoke to move up and down. And the opposite would allow this yoke to move left and right. So you can see that as this yoke is spinning, it allows your shaft to move in whatever direction is required. Plain bearings, usually made from brass, bronze, aluminium alloy or nylon. For example here, tubular or flanged. Very compact, no moving parts, ideal for small electrical motors, light loadings. See here an old drill. There it sits there. Spherical bearings are used where there is movement on parts on different planes. Only small amounts of rotational movement can be accommodated. Good solution for alignment problems, applications of car steering and suspension assemblies. You see the bearing has rotation but also spherical movement. Lubrication. Choice of lubricant is an essential factor in ensuring the proper functioning and long service life of bearings. Lubricant does the following things. It facilitates movement, it avoids wear and premature fatigue, reduces internal friction, ensures that the bearings are sealed against external bodies, reduces the operating noise, and protects the bearing against corrosion. There are 2 choices, grease and oil. Generally speaking, grease is the simplest and most efficient choice because it provides all the functions mentioned. But if the bearing is subject to high loads, the operation is continuous and the rotational speed high, then oil is the ideal solution. That's the end of our video. Hope you've enjoyed it. Hope it's been informative. My name is Robert Kerwin and I'm studying at Blackpool and Fylde College.